Are you a programmer or a software engineer? You might be thinking, what is this guy even talking about? Isn't programming the same as software engineering? Well, my friend, if it was, I wouldn't be here making this video. And after spending countless of hours just scrolling through YouTube and Reddit, I've seen 99% of the people out there just talk about programming, like learning how to code, learning how to crack FANG interviews, and call themselves software engineers. So I decided it was time to pull up my socks and make this video. Actually, I decided it was time to pull up my socks and make this YouTube channel. Well, you see, confusing programming and software engineering can really stall your career because you might end up actually focusing on the wrong thing. So I'll break down the details in this video. If that sounds interesting, let's get straight into it. Before I get any hate comments or dislikes, I would like to clarify that programming is a big part of software engineering, don't get me wrong. A lot of people have this misconception that programming is software engineering. That is wrong. And yes, I'll break that down in this video. So yes, like most of us learn in university boot camps, we all learn how to code, how to write beautiful Java, C++, JavaScript, and then sprinkle in those frameworks like React and all of that stuff to make these beautiful looking applications and whatnot. Well, yes, that makes you a programmer because now you can execute, you can tell the computer what to do through your code. And yes, that is programming. But is that software engineering? I'll get to it. Yeah, so putting together these beautiful looking applications might be websites, could be these iOS applications, Android applications. That makes you a programmer because now, like I previously mentioned, you can execute. So what goes into making these applications apart from the execution part? Well, my friend, that is what software engineering is. To get this straight, software engineering is thinking about the bigger picture. And what I mean by the bigger picture? Well, how does the application scale? How will it handle a massive onslaught of users, let's say on Boxing Day, Black Friday, whatever you want to call it? So yes, there's a lot of things that goes into software engineering. Again, the examples that I just gave right now are a part of software engineering. There's a more non-technical part of software engineering, which I'll get to soon. So let's first start talking about the bigger picture. Okay, so the examples that I gave earlier, scalability, availability, and all of those things which are part of distributed systems. Thinking about that in a timely fashion is very important, especially when developing your application. Just putting together some code which runs and you can deploy it to some server and see a beautiful application and website, that's just the execution part. The planning on how this will scale, how this will be available during downtime, how to make this fault tolerant, all of that stuff put together is thinking of the bigger picture in software engineering. Think about it. Do you want to be in a position where you've worked really hard to code out this application, but as soon as it has users starting to use it, it just goes down, gives this bad user experience, and yeah, people just give you bad reviews. That is something which is going to negatively affect on your app, your company, or whatever. So there's a lot of thought that needs to be put, especially on the backend side of things, on how this application will scale with traffic. And scaling and availability are core concepts of distributed systems, which I feel a lot of engineers need to consider because I've seen most engineers only ever caring about how to use this framework, how to use that framework, how to create APIs. But my friend, if you don't think about how your application is going to keep working when users actually use it, well, that makes the whole difference. Again, I just want to clarify, this is a very specific example for distributed systems, and there's a lot of other stuff that goes into the software engineering side of things. So now now that we're talking about coding, let's also talk about how coding ties into software engineering. Like I mentioned, programming is a part of software engineering, which is the execution part. Now, when it comes to writing your code, you can't just write some shitty ass code. You need to learn how to write good code. Because even though a software engineer, quote unquote, is called an IC or an individual contributor, you're not really an individual contributor. You always work in a team. So your code needs to be understandable. It has to be readable. It has to be maintainable because over time, you're not the only one going to be touching your code. It's going to be a lot of other folks. So taking the time to think on how to write good code instead of just going and hammering out code as soon as a ticket is assigned to you. That's what differentiates a good software engineer. They think about the future when doing your coding tickets and whatnot. And why is that important? Why is having this quote unquote investment mindset important? That again sets you apart as a good software engineer from what you can call a regular programmer. Think about it. Let's say you write some code now, and then after 6 months, a year, you come back and you come back to that code. Most probably you would have forgotten that you had written that code or what it even does. Let me ask you this. How many times have you gone back to your old code and just been like, what the hell is this? I cannot even understand who wrote this shitty code. And then when you look at the Git blames, it turns out to be you. Well, I've been there, I know. And that was an eye-opening moment for me. Because if I myself had such a hard time understanding my own code when I went back to it, it kind of made me realize how hard it must be for other folks to understand what was written and add on top of it. So the maintainability part of it really suffers. A good software engineer would think through a good solution. They would think through a good software design. And when I talk about software design, I mean about your abstractions, your interfaces, and how you abstract away complexity behind interfaces. So let's say when a different service or a different component needs to call your component, they don't need to know how that component works under the hood. They just need to look at the interface. They need to look at how that interface is documented, what the functions or the methods do, and just call it accordingly. And that, my friend, is how you think through before writing code. You don't just hop into it and just start typing away. You think about it for a bit. You understand. You think about various different ways of doing it. Maybe take 10-20% extra time to complete your ticket, but take time to understand what you're really coding out and how this is going to affect the overall system or even the larger system. Because trust me, sometimes the more shitty components you put together, the entire system starts becoming shitty, which is what you don't want, and which is what's going to affect the scalability, availability, maintainability, fault tolerance, and all those aspects of a system. So yes, just whenever you're assigned a ticket, don't just jump straight into it and start coding it out. Take 10 to 20% more time than you usually would to think through the various different ways you might approach this, the different trade-offs that each an option has. If you're interested, you can even consult the senior engineers on your team to understand their point of view, because most times or not, they might have some really good ideas and suggestions for you. Definitely learn the design patterns and whatnot. There are some great books out there to teach you that. So this was again the more bigger picture part of software engineering. Now I want to take some time to also talk about the non-technical side of software engineering. So I think I briefly mentioned a while back that even though you have a quote-unquote individual contributor title to you, it's not technically individual contributions. You are always working in a team. Even when you do coding on your own, it's not always just on your own. You might always be working with someone else, if not a wider team. So let's say you're given a project. Would you just go straight into the implementation without proper planning, design, and all of it? No, you won't. And with the project, you're not the only person assigned to it. You're going to be working with a bunch of other folks. You'll probably be working with other engineering coworkers, probably other senior engineers, product, QA, maybe customer service and whatnot. Well, when dealing with so many different people, it becomes extremely crucial to first, number one, clarify all their requirements. Number two, get an understanding of what features are really required, what features are not required. Number three, clarify that understanding with product and the relevant stakeholders. And number four, once all those requirements are clarified, you start jotting down the features in, let's say, a document. And then once you have all of those features, you start thinking about ways and how you can implement those features. So doing proper trade-off analysis, conducting offline discussions, conducting online discussions, getting buy-in from various stakeholders, just to see what trade-off is fine with everyone. Well, that's what a software engineer does. And again, I want to briefly mention that there's never one best solution. With software engineering, it's always coming to the least worst trade-offs that is fine with you and your team. And these trade-offs might differ from team to team. So your team might be fine with these particular trade-offs, while some other team might be fine with these particular trade-offs. So taking the time to build alignment between the various stakeholders, like I mentioned, building trust, building authority around yourself and your work and how you operate, that plays a crucial difference on how a software engineer operates and what sets a good software engineer apart from a decent software engineer or just a programmer who cares about the execution part of it. A good software engineer, you might do all the high level stuff, you might do the architecting, and then you might assign it to some programmer to code it out for you. So in the non-technical side of things, effective communication or good communication, good documentation to build alignment between folks, and just to build trust and authority are some really crucial skills that software engineers need to develop. And basically what makes a good software engineer good. Well, okay, now that we have touched upon what's the difference between programming and software engineering, we need to know why it is even important to know this difference. Well, not knowing this difference can actually stunt your growth by making you focus on the wrong things. Believe it or not, coding is actually the easy part. The other stuff that I talked about is what takes practice or what takes some time to build your skills on. At the start of the video, I mentioned I've spent countless of hours on Reddit. I really have. Every single day I scroll through Reddit just to find posts like, I feel so lost. I feel burnt out. I have 10 plus years of experience, yet I'm stuck at mid-level. Why? And when I actually go through these posts, all they talk about is how they work extra hours, how they do more tickets than everyone else, how they work over the weekends, yet they see other folks getting promoted over them. They feel stuck, they feel burnt out because they're overworking themselves. Well, kind of gave me an aha moment that I need to talk about this. I remember making a super long Reddit post about this. If you want, I'll link it in the description as well, which talked about how I personally started developing these non-technical skills and which really catapulted my career. Anyways, yes, like I mentioned, most people only ever care about programming because that's what they're taught about. They feel that they need to get better at programming. They need to keep learning all these new frameworks and languages and all of that stuff just to keep growing in their career. That will only help you until a certain point in a career. Above mid-level, the stuff stops mattering. And how you treat and hone in on these non-technical skills of building alignment between stakeholders, building trust, building authority, and just building your overall visibility, that's what starts making a difference. So that's one part of why you need to know the difference. Now the second part, and again, a lot of posts that I've seen on Reddit or even YouTube is, will AI replace me? AI is becoming so good at coding, why do they even need junior software engineers? Well, yes, because execution is what AI can do. So as and when it gets better over time, it can actually replace these junior engineers. So what makes you different? Well, you're here watching this video. You know that programming is not the only thing that you need to work on now, because that can potentially be replaceable. You need to now focus on these quote-unquote non-technical skills. And I know there's a running joke that people hire personality hires. This is not that. And I know sometimes with engineers, a lot of engineers tend to be more introverted. So doing these tasks can be tough, but hey, if I can do it, so can you. I've been introverted all my life. I've been super shy. I used to struggle at talking. I had a stuttering problem, using too many filler words, losing track of thought and all of that. But now, as you can see, I can speak pretty fluently. So with practice, you can do it. And that's what's going to be setting you apart, because now let's say you can start leading projects, you can build alignment between the relevant stakeholders. So you can be the one that pulls the strings and AI is the one that can execute. So now you're actually adding a layer of protection around your employment. So unlike most junior engineers that are replaceable, you will be much less replaceable now. I have no idea if AI can develop these human skills at some point in the future, but hey, till then, at least your job is a lot more secure. Yes, and exactly like I said, so programming starts becoming a smaller and smaller part of your job as and when you keep climbing up the ladder. So you'll start doing less coding when you're senior, even less coding when you're staff, and way less coding when you're principal. Sure, you will never completely give it up, but the kind of responsibilities that you have to handle as you grow in your career drastically changes. You start becoming more and more high level. You start looking at more complex problems. You start coming up with complex architectures. You start building alignment not just between team members, not between teams, between various departments as and when you grow. Because believe it or not, these projects, they go all the way up to the top, and you need to build alignment at all different levels. So trust me when I say taking the time to build these non-technical skills is going to catapult your career. And it's not just you learn it once and forget. You learn it and you use it throughout your career. So yes, that's what a good software engineer does. And that's what even these high up principal engineers do. That's what sets them apart. Sure, the technical skills are top notch as well, but the non-technical stuff is what actually sets them apart, and how they do all the stuff that I briefly mentioned in this video. And as you learn to develop these non-technical skills, you'll also get more chances to take those initiatives, to be more proactive than reactive. You'll find problems in your company, in your teams, or whatever. You'll take it up to the relevant stakeholders. You will start suggesting solutions to these so that you can fix that problem. And there will be a lot of times where this stuff will be put into the backlog, but now you're building visibility. You're telling everyone that you're someone who wants to make impact. So now you start getting that recognition as well. You'll start getting better projects, and yeah, you'll keep improving in your career. So that is why you need to know the difference between programming and software engineering and why it even matters. Focusing on the wrong thing is going to stunt your growth. I've talked enough about it in this video. Sure, at a high level, because I don't want to make this video too long as well. So now you know what you need to focus on and why you need to focus on it. Basically, it's to build a protection layer around your career, to protect you against AI up to a certain point and catapult it as much as possible. So yes, we talked about what programming is, we talked about what software engineering is, and we talked about why knowing the difference matters. So hopefully, I really hope that you found value in this video. I have a feeling a lot of people are going to dislike this video or put some shitty comments or something, but hey, I'm just talking about what I've experienced in my career and what I've seen some really, really good engineers do to help them really set themselves apart in this industry. So if you want to be among the 99% who focus on programming and just focus on learning all this other stuff, be my guest, do it. My job was just to make this video, so hopefully I can open some eyes so that people can start focusing on the other stuff. So anyway, that's it for today, and thank you for watching, and I'm rooting for you.